Now, welcome back to a very exciting tutorial about creating a extraordinary space game, which is already great. We can place some objects on our screen. We have our aliens moving. We have a custom background music, which is this, and now we have to do something to destroy these aliens, and we have to get rid of this this template code here. So let's continue. We just finished our update procedure, so we're updating our screen in every cycle and ask if more than a second has passed since we added the last yield of alien ships, and we're going to create alien ships if it's necessary, and now we are going to make it possible to fire on them. Therefore, we're going to write some mathematical functions. We can do that at the bottom of our file. And we have to do some vector calculations. So we must be able to add something to a vector. We have to be able to subtract something from a vector. We must multiply vectors, and we have to be able to calculate the length of a vector, and we have to normalize a vector. So let's do that one by one and create each function. So let's first say vector add, and we have a two-dimensional coordinate system. So we have 2 points that we have to deal with, and these are CG points A and B, and our function will return a CG point again, and all we have to do to add something to a vector is return a CG point which we'll have to make. So we use the x value of the first vector and add b, and the same with the y part. All right. Now let's create the method for vector subtraction. So again, vector subtract. We've got 2 vectors. And we will return again a CG point. So let's return CG point make a.x minus b.x, and the same with a.y minus b.y. And now we will multiply. This time we will have again we will have one vector and multiply it by a factor. So let's say a.cj point and the factor b, which is a CG float, and we will return again a CG point. So let's return CG point make a.x times b and a.y times b. That's it. And now we want to get the length of a vector. So let's create a function for that too. Length, vector length, and therefore we only get a vector, which is a CG point, and we will return the length as CG float. And if you remember how to calculate the length of a vector, it's actually pretty easy. You just have to use the square of the the square root of the x and y components of the vector, and the x and y component have to be squared. So let's first cast this expression using CG_float, calling square root float, and now we need a CG_float of a.x. As I said, the x component of the vector has to be squared, so times CG_float a.x plus the square of the y component, CF. It's not a CG_float, it's a C_float, which we have to use for the square root function, C_float a.y times C_float a.y. I think that's right. 3 parentheses. Let's build it and see if we missed something. CG_float square root f. Ah, right here. We have missed one CG_float. So now all our components are CF floats, and we have completed the calculation of the vector length. And now let's finish by vector normalization. So let's write a function called vector normalize, and therefore we also just get a vector which is of CG point, and we will return again a normalized vector, which we'll do just by getting the length of the vector that we need. So let's say equals vector length of our point, and then let's return a CG point with the x and y component divided by the length. Alright, that should do it. Now we have all the functions we need, and we can return back to firing torpedoes. And the first thing we need to do is getting a proper function. We don't have one to say when a touch has ended. So let's get rid of touches began, which has created this this standard spaceship, which is coming from Xcode, and we will create the touches ended method, and we'll create by we will start by adding some cool sound effect. So let's say self.run action, and we'll use the SpriteKit action play sound file named, and our file name is torpedo.mp3. Wait for completion until the sound is played again. Let's say no. False. And this actually plays a torpedo sound as soon as we have touched the screen. So now let's get the point of the screen where we touched it. So this is going to be a variable called touch that is of type UI touch, and we'll just use touches, any object, and cast it to a UI touch, because you see we get an error here. We have to cast it to a UI touch. And now let's get the location bar location. This is a CG point. Say touch dot location in node, and the node is self, our scene. And now let's set up the initial location for our torpedo. So we will first have to we'll first have to create a sprite node for our torpedo. So let's say torpedo sk sprite node equals sk sprite node, and we'll again use the image named parameter, and this is our torpedo is called torpedo. And the torpedo has its initial position directly on the top of our shuttle. So let's say player.position. And now we will have to set the initial parameters just like we did with the player. So let's say torpedo.physicsBody equals sk physicsBody. And this time we won't use a rectangle as an approximation. We will use a circle with a radius as an approximation, because our torpedo is actually a circle, and we'll just use the radius of the torpedo, which we'll get by calling size.width divided by 2. We'll set also the dynamics to true. And now we have to assign our node with the category and contact test bitmask again, which we have defined in the last tutorial. So let's add the category physicsBody.category bitmask. This is this time, of course, the photon torpedo category, and our contact is the alien. So let's say torpedo physicsBody.contact test bitmask, and this is the alien category. Again, the torpedo.physicsBody.collision bitmask, set this to 0. And again, and this time we have to say torpedo.physicsBody.use precise collision detection. Set this to true so that we get precise collision detection. And now it's time for the calculations for which we just created some math functions. We will start with the offset to between our spaceship and the between the alien that we touched, or the point that we touched on the screen, and the spaceship, our shuttle. So let's say offset, let's say CG point, and we will do vector subtraction. The vector A is the location of our touch, and vector B is the torpedo position, the start position of our torpedo. And we won't add the torpedo to the screen if you touch somehow below the below the spaceship, because you would fire in the wrong direction. So let's say if offset .y is less than 0, then we'll just return and break and stop this function. If this isn't the case, let's just add our torpedo to the screen. Not add alien, add child torpedo. All right. Now we have to get the direction in which we have to shoot, and therefore we'll use the vector normalization method that we just used. So let's say var direction, and this is a CG point again, and use the vector normalization. And of course we will use the offset to determine in which direction our torpedo should fly. And now we have to define a length of the vector to say how far our torpedo should go once fired. So let's say shot length, also a CG point, and this is actually a vector multiplication. We start we will give the vector A will be the direction, and we'll then multiply it by a factor we know, which will be off the screen. So actually, as long as we are on an iPhone, 1000 should be sufficient to bring our torpedo off the screen. And now let's get the final destination of our torpedo so that we can animate it later. Let's say var final destination, also a CG point, and this time we will add to our the shot length to the position, to the origin of our torpedo. And now we'll have to create a velocity for our torpedo since we are on a iPhone 5. Let me just hard code this. 568 divided by 1, and the duration is a float, and we will cast it directly. And the duration is going to be based on self.size.width divided by the velocity. Alright, now let's set again the action for our torpedo, which is going to work just like we did for the aliens. So we will again create an action array, and it's mutable array, and initialize it. And then we will add an object to this array, which will be an SKAction, which is a move to action, and the location to which we want to move our torpedo is the final destination, and the duration is what we just calculated. This is the move duration, and we'll have to cast this to an NS time interval. So let's use this and place move duration into here, and don't forget the closing parentheses. And now we will have to remove the torpedo again if it left the screen. So let's add another object to our action area and say SKAction remove from parent. And now we can add this action array to our torpedo run action, and we'll say SKAction.sequence, and give the sequence our array as a parameter. So when nothing went wrong and we run the application, we should see and hear our torpedo getting fired in the correct direction. Cool. Nice. As you have seen, the alien ships won't be destroyed at the moment. So we will have to handle this as well. And now we're going to use this category bit mask with this strange looking code we've created earlier. And we'll have to write a function for this as well. So let's just do it below the touch is ended method, and we will call this function torpedo did collide with alien, and we will get two sprites. As a parameter, we will have to use a torpedo, and also we will have to, this is going to be SK sprite node, and we will have to use an alien to check if they collided. So again, a SK sprite node. And let's say when there was a collision, let's print hit, not hot. And let's remove both torpedo and the alien from our screen. Let's add one to our counter, because we have destroyed one alien. And if, and this depends completely on you, how difficult you want the game to be, let me set this to 10 for now. And what we have to do here is going to transition to another scene, which we will be doing in a minute when we have handled the real collision. So let's just comment transition to game over or success. And now let's use the contact delegate, which we have adopted earlier. We're going to use a delegate method of skphysics contact delegate, and we have already set the contact delegate to self, and we will have to use the didBegin contact delegate method. And I'm just copying this the function definition into the project, because auto-completion isn't working as it should at the moment within Swift. So this is actually the definition of the delegate method, and you can easily get that by pressing Alt on your keyboard, clicking on the delegate, and then access the reference, and there you can see all the possible delegate methods, and we will use didBegin contact, and you can just copy the Swift code from here. So we will now have a parameter here which is called contact, and we will use this for two contact bodies. So let's create a first body, skphysics body, and a second body, skphysics body. And we will now check if contact dot body A dot category bitmask is less than contact dot body B dot category bitmask. Then the first body is equal to contact dot body A, and the second body is going to be contact body B. And else, just the other way around. Let's copy that, paste it here. This is B, this is A. So now what does that mean? Contact A and the category bitmask is less than the category bitmask of body B. And when we scroll back to our categories, then we can see that the torpedo is actually less than the alien. So if category, when we go back here, if the category bitmask of A is less than the category bitmask of B, then first body is actually the torpedo, and the second body is the alien. So we can now use that to compare which body, whether our bodies, which body is actually which object. So let's say if the first body dot category bitmask, and we will use the this bitwise operation here. So let's compare it with the photon torpedo category. And if this is not equal 0, and if our second body category bitmask compared with the alien category is not equal 0, then we know that we can use our torpedo didCollide method, and we know that first body dot node is our torpedo as sk sprite node, and our second body dot node is the alien. All right. And now actually our collision test should be working. So let's check this out and see if something happens. Nothing happens yet. And this is because I have used the wrong property here. We cannot use contact. Contact has bit mask. We have to use the category bit mask, of course. So let's use category bit mask in here. Also use category bit mask. And now let's try it again. And let's see what happens. And as you can see, our aliens are disappearing, as well as the photon torpedoes, and we will get a hit message in our console as soon as we have hit one alien. And now what we have to do is actually detect whether the user or the player has lost or if he wins. So when actually an alien hits the bottom of the screen, we want to let the user lose. So let's do that by going back to the add alien function and add a little action here. And what we can do is just move to our next scene, which we'll create in a second. Or let's create this scene first and add a transition to this the sequence of actions. As soon as the alien ship has left the screen, we can jump to another scene, because if it doesn't reach the end of the scene, the end of the screen, then the player hasn't lost yet. So, but let's first create another scene just by selecting our game scene, pressing Command N on your keyboard, and we'll create a Cocoa touch class, which will inherit from SK scene, and let's call it game over scene. Let's create it, and somehow SpriteKit isn't automatically imported, so let's import SpriteKit, which hasn't auto-completion yet. All right. And we will have to write our custom initializer, let's say init, with the size as standard parameter, and a second parameter which we'll call 1, so that we can determine what to print on our what kind of message we want to print on our screen. So let's first set the background color. Let's first call the super initializer, say super init, and we have to init it with the size. All right, and now we can set the background color, which is sk color dot black color, and now we're going to create a message, which is a string, and the message depends. The content of the message depends on whether the player has won or not. So if the user has won, let's say you win, and else let's say game over. Let's this capitalized. And now we'll create a label. So let's say a label, sk label node, and we will initialize this label node with a font name. Label node font named. And now let me show you a cool thing which is called iOSfonts.com. iOSfonts.com. And this is pretty cool because you can get the font name from here. So let's just look for a nice font. Let's say this one, Damascus Bold. And you can then just copy this font name from this side. And all these fonts that you can see here are actually available within iOS by default. So let's go back to Xcode, paste this font name here. Now let's give our label a text, which is the message. Let's give it a font color, which is going to be SK color, white color. And let's position it in the middle of the screen. So position equals CG point make. Self.size width divided by 2, and the same with the height. And now let's add our label to the to our scene. And as soon as the user has seen this message, let's restart the game automatically. So let's say self.run action, and this is going to be an SK action. .sequence, and now we're going to use a slightly different approach, because we can also define all the actions. We don't have to write a separate array. We can put it all right here. This depends on your taste. Sometimes it's easier to write within an array and create it separately, or directly create the array here. We'll use these brackets here to specify that this is going to be an array. Define the first SK action, and this is going to be wait for Xcode to work again, which is now, or not. So let me just try to do that without code completion. So wait for duration, and we'll say we'll wait for 3 seconds for the user to read the message. Let's put in another object into this array, which is going to be again an SK action, but this time we will run a block, code block, run block. And we can use this closure just with some curly braces, open this block, and define a transition, which is going to be an SK transition, equals SK transition. Let's say it's a flip horizontal transition with a duration of, let's say, 0.5 seconds. And we will then create a new scene, which is a SK scene. And this is actually our game scene, this one that we have worked with for the greatest part of this tutorial, and the size is going to be the same size as this scene. And then we will just say self.view present scene, which is, we use the other one, present self.view present scene with a transition. So let's say scene and transition. That's it. Now we can return from our game over scene. So now let's, as I promised, add an action to this action array. Add object, and this is also going to be a run block, SK action, run block, and we're going to use this closure syntax here and do actually the same. So let's create a transition, SK transition equals SK transition dot flip horizontal with 0.5 seconds duration, and then let's say var game over scene, game over scene, SK scene, And this is going to be the game over scene we just created. Initialize now with the size of self. And actually we should get code completion here, but we don't. So let's just say self.size, comma 1, colon false. You should get auto completion actually, as long as we didn't do anything wrong. We didn't. It says extra argument 1 in call because I haven't. I made the error, not Xcode made the error. I haven't said game over scene, so let's use game over scene, and there is the code completion self dot size and 1 false. All right. And now let's present, because at this point, let me just give you a quick explanation why we set it to false. We do that because the alien ship, we are within the add alien method. As soon as the alien reaches the lower edge of the screen and goes slightly beneath it, we will have completed this part of the action sequence. And as soon as this part is completed, we can be sure that the player has lost the game, because we defined it that the player loses as soon as he misses one alien ship. And after all, the sequence doesn't end. It will, after all, remove the alien ship from its parent scene. So at this point, we know for certain that we can present the game over scene. So self.view present scene, the game over scene with the transition. And all we have to do now, and we can actually copy this code and go to our collision, go to our torpedo did collide function and go into this if statement here, because we have defined that if the player has destroyed more than 10 alien ships, we can transition to the game over scene and display a you win message. But what we have to do is we have to set one parameter to true in this case. Not true. Okay. And actually, that should do it. Let's run the application and see if I can hit 10 of these aliens. And you win. Now we should return back to our game, and I'm going to miss one, and game over. That's it. And we'll return back. That's quite fun, a lot of fun. So, have fun developing this this iOS game using Swift and SpriteKit. And as always, if you have questions, feel free to ask them below. And if you want to see something new or different, also comment below. Have fun.